Welcome to Infinity QS's Tales from the Trenches. In this video series, we present real-life quality professionals discussing how they solved important quality and process problems at their facilities. These quality professionals get into the details of how they leveraged Infinity QS software to solve the problem, including how they identified the root cause. Placing too much product in a food or beverage package is called overfill. This giveaway can negatively affect a manufacturer's bottom line, potentially exposing your company to regulatory risk. In today's episode, Quality Manager Ian Farrell will discuss how he used Infinity QS software to control product giveaway, saving his company money and reducing the chance of violating critical weight requirements. We hope you enjoy the video.
Hi, I'm Ian, and for the last 18 years, I've worked as a quality manager in the food and manufacturing industries. In this Tales from the Trenches episode, we're going to talk about overfill, its impact, and how you can use Infinity QS software to reduce it. Product giveaway, also called overfill, happens whenever you fill your packages with more than the declared quantity printed on the packaging. And while it seems like an innocuous, delightful little bonus to your consumers, it brings with it a host of complications and risks. We're going to take a look at some of those risks and complications, at what causes them, and at what you can do to resolve them. I wanted to use an example to show you what I've done to limit overfill, and in the process, what I've done to keep my company's product cost low, keeping us competitive in the marketplace. In manufacturing today, it's almost unheard of to have a manual filling operation. Whether it's chocolate candies, sheet metal screws, or medication, almost everything is filled using automated equipment. This equipment is fast and accurate, but it's not infallible, and it still relies on operator input to function efficiently. Because of this reliance, operators possess the most direct control over how much product giveaway is happening. By giving them an SPC program that focuses on reducing overfill, we can harness the skills of operators to help us limit overfill, optimizing fill weights to reduce costs and reduce the risk of violating net content regulations. In another episode of Tales from the Trenches, we discussed the difference between running in spec and running to target, and how running to target increases process capability, lowers product costs, and improves customer satisfaction. The same principles apply to overfill. A process that is run in spec, not necessarily to target, tends to have results scattered throughout the specification range. Instead of a smooth trend line, it's a jittery mix of high, low, and on-target results, without any predictive ability to know where the next result will land based on the previous results. Because of this, and because of net contents regulations, filling operations become constrained by the lowest likely fill weight and must overcompensate to ensure that even the least filled packages contain the minimum amount required by law. As a result, reduction of overfill takes a back seat to reduction of underfill. What is needed is a way to address the root cause of fill weight variation, so we can eliminate both underfill and overfill simultaneously. Anytime a product is overfilled, the cost must be accounted for somewhere. Either the company loses money, or it must raise the cost of the product to account for the consistent overage. One instance that stands out to me is a situation in which operator practices had unintended consequences that led to a decrease in process capability, limiting our ability to lower fill weights and reduce overfill. In the case of a popcorn filling operation, popcorn travels via conveyor into weigh hoppers that empty into the finished product containers. A typical setup involves anywhere from 12 to 16 weigh hoppers. Each one is a specialized scale that opens and closes to allow product to gravity fill into the containers below. To fill a container, the filling system is programmed with logic that uses the best combination of 8 to 10 weigh hoppers to achieve the target weight while minimizing overfill. When running a product such as caramel corn, the weigh hoppers get sticky and become less accurate. Frequent cleaning is required to keep fill weights consistent. Operators also have the ability to take individual weight hoppers offline, either to clean them or to prevent a troublesome hopper from dumping. The unintended consequence of taking hoppers offline is that the logic now has fewer potential combinations it can use to fill containers. As a result, fill weights start to vary and process capability decreases. In the absence of a structured SPC program, Fill weights are all over the place, unpredictably consuming the entire spec range and cutting into your ability to consistently meet regulatory net content requirements. Governments typically regulate the quantities of products sold to consumers. In the US, the Federal Trade Commission and the Food and Drug Administration are responsible for assuring that companies fill their packages with quantities that match their label claims. For food products, a value known as the Maximum Allowable Variance, or MAV, is established to provide for minor inconsistencies in filling processes. Typically, the MAV for a product represents approximately 10% of the declared weight, allowing for products to be filled with 90% of their declared weight and still be compliant. However, the underfill must represent only a small fraction of a product lot and cannot be compensated for by overfilling other packages from the same lot. It's important to note that the FTC and FDA guidelines and the MAV only apply to the lower end of the fill weight variation. There is no enforcement of overfill. Process capability is a measure of the likelihood that a process will remain within specifications. Consider two machines performing the same process with a specification range of 50 to 100. Both have an average of 75, but when you look at the control charts, you see that process A has a nice tight range of values, with almost all of them centered between 70 and 80. Process B, on the other hand, has values across the entire specification, with concentrations of values near both 50 and 100, caused by operators making adjustments just before the process goes out of spec. While both are running in spec, only process A has high process capability. If this process is a filling operation and the MAV is 45, only process A can confidently be adjusted to reduce fill weights. Any adjustment of process B will shift all results down, causing a significant quantity to be in violation of net contents regulations. Infinity QS software tracks process capability in real time, allowing management to implement SPC rules to optimize processes. One of the most fundamental values of an SPC program is the idea that the data being monitored is acted upon, not ignored. Basically, the squeaky wheel gets the grease. By monitoring control charts and not just relying on 12 and 24-hour averages, it becomes easy to know if a process is using the full specification range or if it's tightly centered around target. Selecting the right combination of SPC alarm rules is critical when attempting to control process capability. Rules such as 2 of 3 in Zone A or beyond, 4 of 5 in Zone B or beyond, and even 8 in a row avoiding Zone C can quickly identify special cause variation that is driving poor process capability. There's no need to wait for customer complaints, failed product inspections, or process upsets. Processes are not one size fits all, and SPC rules shouldn't be either. Infinity QS software allows for endless combinations of rules to be enabled so that emphasis can be placed on detecting special causes that are unique to your products, processes, and customer requirements. By implementing a unique set of SPC rules, problems like overfill and risk of underfill become a thing of the past. In the case of my popcorn fill weight struggles, selecting the right set of SPC rules was the foundation of my successful process improvement project. For me, a combination of 2 of 3 in Zone A or beyond and 7 consecutive points in lower Zone C worked the best. One nice feature of the Proficient software is that you can individually enable and disable the upper and lower versions of an SPC rule. While my goal was improving process capability and addressing both underfill risk and overfill, I found that an asymmetrical set of rules was the most effective. While the 2 of 3 rule helped me drive to target from both the upper and lower specification limits, the 7 in a row rule was there only to help me meet my regulatory net contents requirements. Operators were happy too. Not only were the SPC rules helping to reduce rework, improve capability, and increase profits, they were serving as a notification system for the operators, alerting them to wayhopper issues in real time before a failure or downtime event occurred. Every 3 months, I evaluated my fill weight data and process capability metrics. And after each analysis, I was able to lower my fill targets, saving money without increasing my risk of net contents violations. In my opinion, reducing overfill is one of the most rewarding ways to utilize SPC and continuous improvement. So often, process improvements are restricted by the law of diminishing returns, each iteration taking more resources and yielding more modest results. With Infinity QS software driving net contents control, you are literally taking the same amount of product and spreading it across more consumers during each production run.
We hope this episode of Tales from the Trenches has shown you ways within Infinity QS software to better control your product filling processes so you can save money and avoid regulatory violations. Infinity QS is always there to help. We have application engineers ready to assist you in getting the most value out of your Infinity QS implementation. Reach out to your sales representative for more information and pricing. Thank you for watching, and check back soon for our next episode of Tales from the Trenches.